Hello, and as always, welcome to Random Rundown. Black holes, these infinitely dense points in space, will spaghettify anything that ventures too close. But what is spaghettify, you may wonder? Let's start by defining what a black hole is. So, what is a black hole? Black holes are areas in space with incredibly strong gravitational forces due to their high density, which is so intense that even light cannot escape beyond a certain point. When objects like stars, planets, or spacecrafts get too close to a black hole, they are stretched and compressed in a process called spaghettification, which means getting really long and thin like a big space spaghetti. As astrophysicist Neil deGrasse Tyson once described the process. While you're getting stretched, you're getting squeezed, extruded through the fabric of space like toothpaste through a tube. There are 4 types of black holes: stellar, intermediate, supermassive, and miniature. The most well-known way for a black hole to form is through the death of a star. As stars approach the end of their life cycles, they may inflate, lose mass, and cool to become white dwarfs. However, the largest stars that are at least 10 to 20 times the mass of our Sun will either turn into superdense neutron stars or become stellar mass black holes. Enormous stars reach their end with massive explosions, called supernova, which fling matter into space and leave behind the core. During the star's lifetime, nuclear fusion counterbalanced the inward pull of gravity from the star's own mass with a constant outward push. In the remnants of a supernova, there is no longer a force to resist the gravity, causing the core to collapse. When the core collapses into an infinitely small point, a black hole is formed, with a powerful gravitational pull due to packing such a huge amount of mass, often more than our Sun, into a tiny point. There could be thousands of these stellar mass black holes within our Milky Way galaxy. No black hole is like the others. Supermassive black holes, predicted by Einstein's general theory of relativity, can have masses equal to billions of suns. These cosmic monsters likely hide at the centers of most galaxies. The Milky Way hosts its own supermassive black hole at its center known as Sagittarius A that is more than 4 million times as massive as our Sun. The tiniest members of the black hole family are, so far, theoretical. These small vortices of darkness may have swirled to life soon after the universe formed with the Big Bang, some 13.7 billion years ago, and then quickly evaporated. Astronomers also suspect that a class of objects called intermediate mass black holes exist in the universe, although evidence for them is so far debatable. No matter their starting size, black holes can grow throughout their lives, slurping gas and dust from any objects that creep too close. Anything that passes the event horizon, the point at which escape becomes impossible, is in theory destined for spaghettification thanks to a sharp increase in the strength of gravity as you fall into the black hole. How do we know they are there? We can't see them, right? Since black holes consume all light, astronomers cannot directly observe them like they do with other celestial objects in the sky. However, there are several indications that suggest the presence of a black hole. Firstly, a black hole's powerful gravity pulls on the surrounding objects, resulting in erratic movements that astronomers can use to deduce the existence of the invisible entity in the vicinity. Additionally, astronomers can search for stars that appear to orbit nothing, indicating the possible presence of a black hole. This is how Sagittarius A was identified as a black hole in the early 2000s. Black holes also have a messy eating habit, which often gives away their locations. As they consume the surrounding stars, their immense gravitational and magnetic forces heat up the falling gas and dust, resulting in radiation emission. Some of the glowing matter forms an accretion disk around the black hole. Even the infalling stardust is not always retained by the black hole. Sometimes, black holes eject the matter in a powerful radiation-filled expulsion. Do we have pictures of them? Technically, yes, we have a picture of the black hole in the middle of our galaxy, although we cannot see the black hole itself. Because it is completely dark, glowing gas around it reveals a telltale signature, a dark central region, called a shadow, surrounded by a bright ring-like structure. NASA and other space agencies are using satellites and telescopes that are traveling in space to learn more about black holes and their behavior in the universe. From their incredible gravitational pull to their ability to bend and warp space-time, black holes remain a topic of intense study and speculation. So whether you're an astrophysicist or a curious observer, We hope this video has given you a glimpse into the enigmatic world of black holes. As always, thank you for watching, and we'll see you next time. Remember to subscribe to Random Rundown for more.